Welcome back to Inside Sendium, our short series where we talk about the people behind Sendium, about SMS infrastructure, open source telecom software, and the thinking behind the project. I'm Dimitris Petrakis, community manager at Sendium, and today we're continuing on the technical side of the project. In the previous episode of Inside Sendium, we had Manos Alefragis with us, who took us into routing, TPS, and real-world messaging control. Today, in episode 4, we will look at the core gateway layer itself. I'm joined by Pavlos Lykakis from the development team, and our topic is building the core gateway layer, a high-level technical look at how Sendium is built. Now, this will not be a deep code walkthrough. The goal is to understand the main architectural thinking behind Sendium, how messages enter the system, how the gateway layer needs to handle real-world traffic, why routing and protocol handling matter, and what makes SMS infrastructure different from a typical web application. Pavlos, welcome to Inside Sendium. Great to have you here.
Thank you for having me.
All right, yeah. Pavlos, to start, could you briefly introduce yourself and explain your role in the Sendium development team?
Yes, of course. I am Pavlos Lykakis, a senior software engineer, and I've been with Scitech for more than 7 years. I've been involved in Sendium from its early stages, contributing to the project's overall architecture and core gateway layer.
Okay, all right. So, from a development perspective, what makes an SMS gateway different from a typical web application or backend service?
Okay, so it's really a combination of all those things. A typical web request often ends when the server returns a response, but an SMS message has a much more longer life cycle. The gateway keeps SMPP connections open, controls throughput, manages queues, handles drop connections, and waits for the delivery receipts that will arrive later. It also has to deal with the encoding, with multiple messages, provider-specific errors, and routing decisions. So we are building a system that carries operational state over time, not just another request-response service.
For people who are not deep into telecom software, when we say core gateway layer, what are we actually talking about, Pavlos?
At a high level, I will divide the core gateway layer into 4 main parts. First, there are the entry points that receive messages, either through the SMPP server or the HTTP endpoint. Second is the routing engine, which decides where its message should go. Third are the workers that maintain the outbound SMPP connections and send traffic to the providers. And finally, there is the delivery receipt service, which tracks the provider result and forwards the delivery status back to the originating system.
Oh, I see. And you mentioned delivery receipt handling as one of the core parts. Is tracking a message after it has been submitted more complex than it sounds?
Those are 3 different stages. First, Sendium validates and queues the message and returns its own gateway ID, the Sendium ID. Then, message is routed to a provider which responds, returns its own message ID. The finally delivery receipt may arrive seconds or minutes or hours later using that provider ID. Sendium links those identifiers so it can match the receipt to the original message and return the status. The correlation is essential for visibility and troubleshooting.
I see. And Sendium can sit between systems that use HTTP and systems that use SMPP. Can you give us a practical example of how the gateway bridges those protocols in a real message flow?
A common example is an application submitting a message through Sendium's HTTP API while the upstream provider accepts SMPP. Sendium converts the request into its internal message format, routes it, and sends it through an SMPP connection. Later, the delivery receipt comes back over SMPP and can be forwarded to the application through an HTTP callback. The important part is preserving message IDs, addresses, encoding, and delivery context, while the protocols each side are completely different.
Routing is one of the most important parts of SMS infrastructure. From a high-level development perspective, what makes routing challenging?
A routing decision rarely depends on just one thing. It may depend on the customer, the destination, the center, the type of message, or the current capacity of a route. And the result still needs to be predictable when traffic conditions change. In Sendium, routing is based on explicit ordered rules, so operators can understand why a path was selected. If fallback or rerouting is needed, that policy should also be deliberate and visible.
And in real-world SMS operations, things can fail. Like routes may slow down, connections may drop, and providers may behave differently. How does this reality influence the way you build the gateway layer?
The starting point is to assume that things will fail. A provider throttle, a timeout, a dropped connection, and a permanent rejection don't mean the same thing, so they shouldn't trigger the same response. The gateway needs to retry temporary problems carefully, reconnect lost sessions, and clearly report failures that can't be recovered. From a developer side, reliable infrastructure doesn't only mean that the process is running. It means failure states are controlled, visible, and testable so operators can understand what happened.
One thing technical teams often need is control. How important is flexibility and configuration in a system like Sendium?
It's very important because providers and operational requirements can change quickly. Teams shouldn't need a code change for every routing rule or connection adjustment. Sendium separates credentials, SMPP worker settings, and routing policy into files that operators can inspect and review. Routing and many selected settings can also change while the gateway is running. When behavior is hard-coded or hidden, incidents are harder to explain. Visible configuration and open source code gives teams much more ownership and control.
And when building Sendium, how do you balance the needs of developers with the needs of people who will actually operate the gateway in production?
I don't really see developers and operators as completely separate audiences. Clear architecture, automated tests, and documented behavior help developers, but they also make the system easier to operate. On the operational side, we provide visible configuration, lifecycle logs, and runtime metrics. We also try to test complete message flows and failure scenarios, not only parts of the code. The goal is that an operator can understand what the gateway is doing without having to read the source code first.
I see. As a developer working on Sendium, what would you like other developers or technical teams to look at first when they explore the project?
I think the best way to start is not by reading the source code in every class, but by following one message. Read the README and the architecture guide, run the Docker quick start, and trace a test message from the entry point through routing, provider submission, and the delivery result. After that, the code becomes much easier to understand. The most useful feedback is based on real provider behavior, especially around routing, multi-part messages, delivery receipts, and reconnects.
You said read the README, so I guess everybody can read the README on GitHub, correct?
Yes.
Yeah, all right. So we will also place the GitHub link in the description of this video. But Pavlos, in the meantime, I want to thank you very much for joining this episode of Inside Sendium. I think this was a very useful conversation because it gives people a clearer idea of what sits underneath an SMS gateway. It is not just about accepting a message and sending it somewhere. There is protocol handling, routing, reliability, configuration, operational control, and a lot of real-world telecom behavior that the system needs to deal with. And this is exactly why the core gateway layer matters. It is the foundation that everything else depends on. Now, for everyone watching, Sendium is open source, so you can explore the project on GitHub, as I said earlier. Read the documentation, as Pavlos also said. Test it and join the conversation. If you're a developer, telecom engineer, SMS provider, aggregator, or technical team working with messaging infrastructure, we would love to hear your feedback. Now, this was Inside Sendium. We'll be back in 2 weeks with another short conversation from behind the project. In the meantime, thank you for watching and see you soon. Take care.